The circle C has the equation x squared plus y squared plus 4x plus 4y minus 17 is equal to 0. The line L has the equation 7x plus y plus k is equal to 0. If L contains a chord of a length root 50 of C, the circle, find the two possible values of k if k is an element of the real number set. So we're going to start by getting the centre of the circle. So we take the coefficient of x, which is 4, we half it and change the sign to get minus 2. And the coefficient of y, which is 4, we half it and change the sign to get minus 2. So minus 2 is the centre of this circle. Next we have to get the radius of the circle. So we're going to use the square root of g squared plus f squared minus c formula. So the g is minus 2 squared is 4. The f is minus 2 squared is 4. And we have minus c, so you get minus 17, which is plus 17. So the square root of 4 plus 17 is the square root of 25, which is 5. So 5 is the radius. So we're going to draw out a rough diagram of our circle. So here we have our circle, centre minus 2, and we have the radius is 5. And we have a chord which cuts through the circle, and we have two possible values of k. So we have two possible equations of the line. So I've just drawn in here one of the chords. So this is one of the possible lines, and I've drawn in the other possible chord, or the other possible line. So one of our circle theorems tells us that the radius that is perpendicular to the chord cuts the chord in half. So this is the centre, and if this radius was extended out to the edge of the circle, it would literally cut this chord in half. So this point here would be the midpoint of the chord. So remember, we were told in the question that the chord is root 50. So therefore the distance from this midpoint to the edge of the circle is going to be half of that. So it's going to be root 50 over 2. So I'm going to label this as q. So the length of q is root 50 over 2. So if q is half the length of the chord, then q is root 50 over 2. If p is the perpendicular distance from the centre to the line L, so from the centre to the line L, which is the chord, we're going to call this length p, the perpendicular distance. Then by Pythagoras' theorem, p squared is equal to r squared minus q squared. So we know that Pythagoras' theorem is c squared equals a squared plus b squared, where c is the hypotenuse. So if we draw on a right angle here, we can see that this is a right angle triangle, with r, the radius of the circle, which is 5, being the hypotenuse, and p and q being the other sides, the a and the b. So subbing into the formula, we get r squared equals p squared plus q squared, and we can rearrange so that we have p squared equals r squared minus q squared. We know that the radius is 5, so 5 squared is 25, and we know that q is root 50 over 2, so root 50 over 2 squared is going to be 50 over 4. So root 50 over 2, the root 50 times root 50 is 50, and 2 times 2 is 4. So we get minus 50 over 4. 25 minus 50 over 4 is 25 over 2. So p squared is 25 over 2, so p is the square root of 25 over 2, which is 5 over root 2. So p is the perpendicular distance from the centre to the chord, and it is 5 over root 2. The perpendicular distance from the centre to minus 2 to L, the line, 7x plus y plus k is equal to 0, is 5 over root 2. Thus, we substitute into our formula, which is the formula for the distance from a point to a line, and we let it equal to the perpendicular distance that we just worked out, which is 5 over root 2. So we need to decide what's going to be our a, b and c, and what's going to be our x1 and y1. So we take our line, which is 7x plus y plus k is equal to 0, and we label it a, b, and c. So a is 7, b is 1, and c is k. And then we take our centre point, which is minus 2, and we label it as x1, y1. So x1, y1. So we substitute into our formula. So we end up with the modulus of 7 times minus 2 plus minus 2 plus k. And that's all divided by the square root of 7 squared plus 1 squared, and we let that equal to 5 over root 2. So 7 by minus 2 is minus 14, and minus 14 minus 2 is minus 16. So we get minus 16 plus k, or k minus 16. Our denominator, we have the square root of 7 squared plus 1 squared. 7 squared is 49, 1 squared is 1, so we get root 50. So multiplying across by root 50, we're left with k minus 16 with our modulus on the left-hand side of the equal sign. And we get 5 over root 2 times root 50 on the right-hand side, which gives us 25. So since we have our modulus symbol, what we have to do is take what's inside the modulus symbol, which is k minus 16, and let it equal to what's on the right-hand side of the equal sign, which is 25. And then we also let it equal to minus 25. So we take whatever is on the right-hand side of the equal sign, we let it equal to the positive and negative of that value. So solving for k, we get k is equal to 41, where k is equal to minus 9.